Okay, example 1, I'm going to show you how to use the first derivative test here. So we have our function, and the first thing to do is let's look for critical numbers. So we're going to need to find f prime. Now this is a quotient function, so we want derivative of the numerator times the denominator minus derivative of the denominator times the numerator, all divided by denominator squared. All right, that's 4x to the fifth minus 2x to the fifth minus 2x over x to the fourth, which is 2x to the fifth minus 2x over x to the fourth. And we see it's undefined at 0. We're going to divide out that x, though. We won't lose the fact that it's undefined there. So we'll have a 2x to the fourth minus 2 over x to the third. Okay, now we set it to 0 to find the critical numbers. So that gives me this, which gives me x to the fourth equals 1. So x is plus or minus 1. Those are the two real solutions. Okay, now there's also a place where the derivative is undefined, and we just make a note, undefined at x equals 0. However, f of 0 does not exist. It's also undefined, so we don't need to examine that particular point. However, when the derivative fails to exist there and the function fails to exist, we do recall that that might be a vertical asymptote. In fact, it is a vertical asymptote. And when you do the first derivative test, you have to keep in mind those places where the derivative goes undefined. And this is one of them. Even though the function isn't defined there, we still want to keep an eye on this. So when we set up our first derivative test, I'll show you how to handle this so that you don't mix things up. So we're going to do this. Here's the test. That's how we administer the test. Make a chart. We put our numbers on. We have a -1. I'm going to put 0 in there, and I'm going to put 1. So I'm going to include the undefined place where I have an asymptote. Okay, now those are my, I can say I've got it partitioned according to my critical numbers and the vertical asymptote. Okay, so partition. That's not the right spelling there. Let's get that right. Partitioned with criticals and vertical asymptote location. Now, let's pick the test points. This is the next part of the routine here. So I'm going to pick test points. I need a point to the left, -2. Need a point in here, -0.5. Need a point in here, 0.5. Need a point here, 2. So these are going to be my test values. And I'm going to fill in chart based on those numbers. Okay, so in here, I already know this is a 0, and I know this is a 0, and I know this is undefined. I'm testing these blue points here. So off in the margin someplace, we'll do our testing. What's our calculations? F prime of -2. And I will use my simplified version over here. I'll have 2 times -2 to the fourth minus 2 over -2 to the third. That's going to be 2 times 16 is 32 minus 2 is 30. Down here you have a negative 8. It's less than 0. That means that the function is decreasing in that interval. To the left of negative 1, all the way up to negative 1, it's decreasing. Okay, that's what our theory tells us. Now we'll test that next point, f prime of negative a half. And let's see. Okay, and now we'll do our computation here. Here we are down here. Okay, f prime of negative half. Okay, let's see, we've got 2 times negative 1/2 to the 4th minus 2 over negative 1/2 to the 3rd. That's going to be 2 over 16 is 1/8 minus 2 over negative 1/8. Now, without doing a lot of work here, you can see that numerator will be negative, denominator is negative. We have a positive result, greater than 0. So we're increasing here. Okay, now, what does that tell you? Before we move to the next point, tell you what it says. It says we have a function that's coming in, decreasing, it looks like this, and it's smoothing out to a 0 horizontal, and then begins to increase again. So that means it must look like that. We have a relative minimum at this point here. When x is negative 1, we have a relative minimum. Negative 1, and we would need our function value there. We can come back later and get that. Let's move on. We need our next value here. We need to calculate over here f prime of 1/2. Well, that's going to be 2 times 1/2 to the 4th minus 2 over 1/2 to the 3rd. And the numerator is basically still going to be that 1/8 minus 2, but the denominator is going to be a 1/8. So this quantity is negative. That means in here, let's stick to that same color. And here, you're going negative again, which means at that vertical asymptote, what happened was this. Let me draw that in. You've got, it's increasing, so it's coming along like this. I'll just say it's coming in like this, up to the asymptote, and never touches it. On the other side of the asymptote, it's coming down, like that. All right, so we see something to help us understand the graph a little better. Okay, so coming down, now we've got to test one more point, f prime of 2. Fact is, it comes down to 0. In other words, 0 slope. That's what this 0 means. So the question is, does it go back up, which would make this a relative minimum, or does it go down? So let's check. F prime of 2 is 2 times 2 to the 4th minus 2 over 2 to the 3rd. That will be 30 over 8, which is positive. So it actually did come back up, and it's coming back up like this. So we have another relative minimum here, and that's at 1. And now we might as well get those numbers. Let's look at our original function here, which was x to the 4th plus 1 over x squared. So x to the 4th plus 1 over x squared. That means f of negative 1 is 1 and 2. 1 and 1 is 2 over 1, which is a 2. And f of positive 1, positive 1, will be also a 2 over a 1, which is a 2. Okay. So that's it in this determination. So we see a relative minimum at -1, 2, another relative minimum at 1, 2.